All right, hi everybody. We're here to talk about a tool we built for Kubernetes cluster security. My name is Vincent. And
I'm Valentine.
That's Valentine. I'm currently working at OpenBook as a hacker in residence. We're a social media company who aims to replace Facebook in the future. I know how to quit Vim, and I'm a really avid Vim user. And hopefully you'll see some Vim pros during the talk somewhere.
So my name is Valentine Mairet. I work at the KPN Red team. I used to be on the blue side working for Fox IT and ADN in the Netherlands, and now I've come to the red side. I know how to quit Vim, but I prefer to use Nano. And actually, this is my first talk, so bear with me. I'm a bit nervous, so I hope this goes well.
So now the outline of the talk. First, we do a little bit of introduction. There is a lot of Kubernetes nomenclature we will explain. Then we'll talk about the several attacks that are possible in Kubernetes. Then we'll show you our logging architecture, basically how to use Fluent, Elasticsearch, and Kibana. Then we'll talk about the traces you can see in the logs when we do certain attacks. And then we'll show you around the alert system, the security dashboard, and do some demos. Unfortunately, no live demos, because some stuff with networking was quite hard to mimic. So we have made some recordings. Oh, wow, that's really sensitive. So what is Kubernetes? Well, Kubernetes is a container orchestration tool. It's written in Go mainly, and in 2014 it was released by Google. It's now part of the Cloud Native Computing Foundation, and it usually runs with Docker. Also, Kubernetes is number 2 on the most active GitHub repository, with the Linux kernel, of course, being the absolute number 1. So that means it's a lot of ongoing development. It's a very alive project, and it's also the most well-known and the most used container orchestration tool that's currently around. With Kubernetes in 2014, there was not a lot of security in place. When I was doing a red team exercise at KPN, I found on the internet an exposed cluster in 2016, and every API call I made to that API endpoint was admin. And that's because in version 1.9, they mandated use of role-based access control, which basically applies authorization to the cluster. And was also a problem with the Kubernetes dashboard. It allows people to easily manage an interface with the cluster. And if it was exposed to the outside, just logging in also meant you were cluster admin. But they changed a lot of things, and nowadays it's a lot harder to do that. And they used to have, and I see a lot of clusters have this, they have plain text secrets in the etcd, and etcd is basically the secret manager of the cluster. And since version 1.7 and version 3 of etcd, which is built by CoreOS, you can also encrypt the secrets, which adds another layer of difficulty for attackers.
So for people who have no experience in Kubernetes, we have prepared a nomenclature table for you. This is basically copy-pasted from the Kubernetes website. And these terms are going to be used in the talk. So we're going to talk about nodes. So a node is a worker machine in Kubernetes. Secrets, these are files or a set of files that contain authentication tokens, credentials, SSH keys, everything that you need to keep secret. Namespaces, basically Kubernetes abstraction to support multiple virtual clusters. And a pod is a set of running containers in the cluster. And a container, I think everybody knows this, but it's basically an executable image that contains software and all of these dependencies. The kubelet, which is an agent that runs on nodes and makes sure that containers are running in a pod. kubectl or kubecontrol, which is a command line tool for communicating with the Kubernetes API server. And a daemon set, which is something that ensures a copy of a pod is running across a set of nodes in a cluster.
So this is an image of a basic cluster with 2 nodes and 1 master node. Inside the master nodes, there are a couple things happening. There's always a kubelet scheduler, a kube controller, and also etcd is in there. And it also hosts the main Kubernetes API. The nodes communicate with the Kubernetes master API, and all the authentication goes through the actual master API. The node communicates with the containers, and of course the kubelet node needs to make sure that the containers are alive. And if I was to try and spawn a pod, it goes from the master to the kubelet API. So there's a lot of proxying involved. So the arrows are actually proxying through requests back and forth, and that's also where the latest CVE came from. So now we talk a bit about why we are here.
Yeah. So what are we exactly doing here? That's a question everybody asks, but you know. So we're here to present a monitoring tool. So this monitoring tool, in order to build it, we configured a logging architecture for Kubernetes to store audit logs. And we performed analysis on these logs to detect and label specific events. It can be malicious events or basically events you want to keep track of. And we created a security dashboard for Kubernetes, which you will see in a bit. So the reason why we created this is because we couldn't find any explicit resources online on how to audit Kubernetes. And there were no tools available to label activity in your clusters, to basically have visibility over your clusters. And there was no security dashboard like the one we created. So this is why we're here.
So there are a lot of attack methods for Kubernetes, and we're going to run through a couple of them, but there are probably a lot more, and a lot more incoming, because Kubernetes security, I think, kind of got a kickstart. So one of the common things that is actually possible on a lot of clusters is that it's possible to create a pod in privilege mode. When you create a pod in privilege mode, it basically gives you the same right to mount block devices as if you were on the actual node machine. And if you run it as root, then you can basically compromise the entire node. And from there on, you can also get to the master. Another one is creating pods with a host path. A host path means you want to mount, share a file, a directory on the node. So let's say you do host path root, you can actually mount the entire root file system of the node. Other attacks are abusing privileges, privilege pods. At times you can maybe get a code command injection in a pod that's enabled as privileged, or you can also start abusing and stealing tokens. Maybe there's a path reversal, which allows you to get the Kubernetes token, and then maybe you can use it to log into a dashboard. And there are also some methods of deploying some default configurations. In some cases, even there's an unauthenticated master API where you can just basically send to the API, execute a shell on this command, and you obtain a shell. But there are like endless possibilities. There we go. This is the first YAML file. If you are willing to commit to going with Kubernetes, then you're going to write a lot of YAML, because they love YAML. I don't love it that much. But this is, for instance, a privileged YAML file. This spawns the pod into a privilege mode, and which allows you, of course, to compromise the node. The second one is a host mount. Here you can see in the highlighted area that we mount the path, which is basically the root of the node, into the root folder. So when we would apply this pod, then we can mount indeed the file system. And if we're running as root inside the pod, then we're also root on the node, which is quite interesting. And that way you can add reverse shells to cron jobs. You can put authorized keys in there. You can put your user into sudo, remove the root password. Possibilities are truly endless. So now we talk a bit about our logging architecture. We're using Fluent. First we need to enable audit logging. So in Kubernetes, there's a Kubernetes API server where all the requests are routed through, and you can enable audit logging by appending the following lines to the configuration. This basically tells Kubernetes to start auditing and save everything in a JSON file. The JSON file is very verbose. I'm going to say this a couple more times because it is truly very verbose. And what you also need to do in this case is you need to create a host mount to var log on other nodes. And then you can just, the Fluent configuration will actually get the log files from this directory. We will post, after our talk, we will post our configuration files and point it to our GitHub, so you guys can have a look at how it's done. As you can see, the logging is quite verbose. I had to omit a lot of lines to make this fit, but it even caches requests and responses, so you can actually see what is allowed, what's not allowed. You can see the status of everything. And it's, of course, a lot of YAML, and it gets converted quite easily to JSON. And as I said, it's very verbose. So how do we log? Well, we use Fluent. Fluent on their website has a configuration for you. It's also a YAML file, which you apply to your cluster, and it automatically downloads a Fluent container. Then you just need to point it to Elasticsearch, tell it where the logs are, and it will start streaming the logs to your Elasticsearch cluster. But it also is, it's a daemon set, which means that if you have like 50 nodes in your cluster, you apply the Fluent daemon set, which means it will create on every on every node, your Fluent pod. This is also great for lateral movement. If you are allowed to create a daemon set, you can also use it to instantaneously have a shell on all the nodes. What we also did, because we had to use some extra modules for Fluent, which need to be compiled at runtime, we created an init container. And the init container basically fetches resources, install header files, installs the compiler, and then compiles the gem plugins. And then when the init container dies, everything is compiled, and the tools are not left over in the container. And we used Elasticsearch because Elasticsearch is quite flexible. It's quite easy to set up. And of course, it works really well with Kibana. We had some problems though. If you have a cluster with multiple nodes, what will happen is that the same audit logs will be pushed multiple times at some point. So you need to create like a unique constraint so you don't get collisions and have Elasticsearch complaining about duplicate entries. We're not the first one that have this problem actually. There are a lot of people. There are also some variations that happen in the Elasticsearch mapping because sometimes the request object and the response object that you get from the Kubernetes audit logs, they are not the same. So what will happen then is that when the first response object is mapped by Elasticsearch, it creates this specific method of how the objects are imploded and laid out. So it's very nice. You can recursively go to your nested JSON. But then when you get another response object that does not match the made mapping, Elasticsearch is basically going to stop working for you. So we create one JSON response object as a string to work through that. Of course, the idea of resolving this came from that post there, and of course, when you see the configuration files, we give the credit to the founders of this solution.
So to visualize this, so we're back at our original Kubernetes graph. So how it works with Fluent is that you have a Fluent container inside your node, inside a pod. And this container is mounted on the var log in the file system. So it accesses directly the logs from the file system. And then how it fits in the big picture with Elasticsearch is that this container will communicate with an Elasticsearch instance, and we can visualize this in Kibana. And this is basically the output in the Kibana table. There's much more information than this. So here we have timestamp, user, request made, user agent, and method, Kubernetes method. So we have much more information than this, but this fits on the slide, so that's why we truncated it. Yeah, basically that's what you get in the logs in Kibana.
So there are some traces we can show you around from common uses. I call them attack traces because when I'm doing a Kubernetes assessment, the kube control binary is a post-exploitation tool. It's really awesome. You can download it statically from the website, actually. Here you can see some common API usage. We have the user agent, we have the request URI, the Kubernetes method, and of course also the username. Is it there actually? Yeah, the username is there. In the next one, you'll see people trying to obtain secrets. As you can see, they're mainly being done with the kubectl application because of the user agent header. And you can also make rules for enumeration or dumping of secrets because that's actually what an attacker will do when he tries to laterally move through the cluster. Here you see some kubectl exec commands. As you can see, they're all in a GET request. The parameters are there. And also here we can see the user who invoked this, even the source IP. So if you want to do some banning, we can do that as well. There's one problem though. We cannot see interactively executed commands. So a lot of times, what I do, I will get a shell, and then if you use the kube control command, it will send this request to open bash. Then it will negotiate a WebSocket connection, and then all the actual shell information, output, input goes over the WebSocket. Kubernetes currently has no way of logging that. But if someone pops a shell on your most sensitive servers in production, then I think it's a pretty good reason to have a look at it. What we also did, because we think privileged containers might be a threat, we created a small dashboard item to show you when it's allowed to create a privileged container. So if I create a privileged container, there will be one entry here that says the authorization plugin allowed me to spawn a host escape container with that user. So you can get a pretty good overview of what's currently going on there. And it's a good indication for compromise attempts.
Yeah, so moving on to the alert system. So because we were able to see this information in the logs, it gave us the idea to basically parse these logs and perform some regex matching and to detect specific attacks. So this is the alert system. We called it KSCOP because it sounds cool. And it's basically a helper for Kubernetes security monitoring. And how is it a helper? Well, it makes the analysis of Kubernetes audit logs easier, and it provides, it basically classifies these logs as labeled events. So, for example, the get secrets or creating a pod will be labeled, so you don't have to look into the request yourself, using regular expressions. And it provides more clarity about events because it will also give you information about where was this request made, which pod, which container, everything. And KSCOP, the technical details of it. It performs static analysis on the date range, so you can give it, I want this from, I don't know, March 12th to April, and it will give you a static analysis of the thing and put it in Kibana. And it can also perform streaming analysis in almost real time, almost because we've actually noticed that there's a slight delay for the logs to get into Elasticsearch, so we make the program wait a little bit in order to be sure that we fetched all the logs that have been generated. It uses the Python API from Elasticsearch, the Elasticsearch client in Python, and it's multi-threaded for extra speed. So this is a nice little graph of Kscope. So it fetches, so you have three components, the fetcher, the parser, and the pusher, and it uses synchronized queues in order to simultaneously fetch, parse, and push to Elasticsearch. So it fetches logs from Elasticsearch, it parses the logs with a set of regular expressions, and it pushes alerts back to Elasticsearch, so labeled events with a bit of information about them. And this is the logo, by the way. I forgot to introduce it.
A very nice logo.
So how does it fit in the big picture? Well, it's basically here connected with Elasticsearch and communicating back and forth with Elasticsearch. And this is what it looks like in Kibana. So you have the timestamp description, the user, the namespace, and the pods concerned. The description shows like pod enumeration of all namespaces, attempt to get all secrets from default, so it provides information about what exactly happened, and additional things like the user, the kubectl command is also in there, and there's much more information that you can, so you can make deductions yourself about the events. But it does have some limitations. So the classification is a one-to-one mapping because we're mapping regex to event. So we cannot yet correlate multiple events, which would be nice in order to detect more complex attack traces. And the rules so the detection rules, they're inside the code. So it would be nice to be able to add rules in some kind of interface. However, these limitations are actually potential for future work, and we do plan on extending this. So, with future work, we could create an interface for adding new rules to make it easy to add rules and delete rules, correlate multiple events to detect more complex attack traces, or even be able to follow an attacker throughout his movements, his or her movements in Kubernetes. We could actually integrate triggers. So, for example, if you have an attack on your asset, like it's at CD, which is a very important pod container. You could basically generate a SMS or some kind of email or message to basically the guy or girl who's responsible for your Kubernetes instance. And also we could connect the alert system to Kubernetes itself. And the reason why this would be handy is, for example, if you see incoming requests that are malicious from a specific IP, well, you could actually block the connection from that IP. So now we move on to the Kubernetes Security Dashboard, and we're going to present this live. So we're going to pray to the demo gods that it still works.
I think first we have a video, and then we... Oh, okay, yeah.
No, first it's just the... Oh.
Is it readable from the back?
Okay, so this is our...
Zooming in maybe for the guy.
Oh.
Yeah.
Okay, this is too much. Okay, so... Does everyone see? I think that's good. Okay, so this is the dashboard in Kibana. So here we have an overview of all the requests that were made across the cluster, with the username from where this request originated, the URL, and the user agent, the method, timestamp. And here all the, so we generated some alerts beforehand, so you can see what they look like. So here we have a nice little pie chart for the different alert types that have happened in your cluster so far. So enumeration alerts is when you try to get information about pods or specific namespaces. No, just pod. Then execution, so command execution that happened in your cluster. Tempering alerts are basically when you created or when someone created or deleted the pods. And secrets when someone tried to access your secrets.
Oh, phone. Okay, there you go.
User activity, so you have different users of your cluster. You can see which one have been more active than others. All alerts here, so the description, the user, namespace, pod, Here you can see information request. So someone tried to retrieve information from this namespace or from this pod in this namespace. Here we have some enumeration of all the pods. Command execution here. Yeah, basically a lot of things. Here an overview of the commands that were executed inside the cluster. So on this specific container, etcd, this is really bad if someone has command execution there. The different kubectl commands that were executed as well. How many people tried to get your secrets? Unauthorized, so requests that were made that were unauthorized are also logged, and this one that we already showed about spawning a privileged pod.
We're still playing a bit with the verboseness of the logging because I'm trying to see if I can also catch some ODs in the logs, but we need to apply more logging to different components. So there's a bit of pollution in the kubectl commands. Usually only are going to monitor actual users. You will see some service accounts in there, but we'll mainly try to monitor users that actually have those rights to run kube control commands.
So Kibana itself is pretty flexible with creating new alerts. So if you're interested in other things, you can even create your own visualization. We have a specific dashboard as well for your crown jewels. So if you have specific assets inside your cluster, specific pods that you really want to keep track of, then you can just create a dashboard for this one and filter on, for example, here we created on etcd. So we see all the activity that concerns etcd. All the commands that were executed and everything. So, the video?
Yeah.
Okay.
We don't have really good video editing skills, so we will show you two sequential videos. The first video you'll see someone in a shell running commands on the cluster, and in the second video you'll see the correlation of events in the monitoring system. So first thing that happens here is running get pods to see if we can actually get some pods. We'll run it again in all namespaces. And we're currently a low privileged user that is not allowed to list resources at the cluster scope. The user will try to enumerate a bit more, trying to get some namespaces. And these unauthorized events, they're also feeded into the security dashboard, because I think it's very interesting when someone is trying to do things they're not allowed to do. Here you see some very great Vim skills. What we're doing over here is we're setting the security context privilege to true, and we're adding a volume mount of the root file system of the node into our container. So then we're trying to apply it with kube control. There you go, creating the pod. We'll wait a couple minutes, a couple seconds, not minutes. And then afterwards, we'll try to get a bash shell into the container. And what you'll see then is that first we check, of course, if it's created. And this, of course, creates lots of events in the security dashboard. And now we spawn a shell with a TTY in host escape, which is conveniently called host escape. And we'll see if we can actually cut shadow file or pass.wd, because it looks like we mounted the node. With the security policies, you can restrict namespaces from creating privileged pods, which will create new security events, which you can also add in the dashboard if you wish. And as you can see here, it was quite trivial for us to compromise the node. That's the awesome tool we use to record the desktop. Now we'll look at the correlations in the dashboard. So
we're back on the dashboard. And we're basically waiting for the alerts to come in. So there's the slight delay from the case scope, but there's also, because Kibana refreshes every 5 seconds, so there's also that delay that's added to it. So the first alert was a pod enumeration alert. Actually, it's already there. And then we can see that this command was executed. And basically, the user who executed this command didn't have the permission to do it. So you have this unauthorized request alert. Now we're waiting for another thing that was unauthorized.
Now we're spawning the pod, I think.
Yeah. The next step was a new privileged pod that was created. Yes. So it pops up here, and it should get to the alerts overview as well soon. Yes. So it's there, and you can see that it basically got created here. And then the next step is command execution. So here you see that bash was open. And it's going to pop up in the others as well. Kibana refreshes. Yay.
And there you go.
And actually, the tool also shows which command was executed.
So there are some exploits that only execute one specific command, which can be useful to show in the list. But some attackers prefer interactive shells, and then there's not a lot you can see.
Also, one thing useful to mention is also good for detection is that some commands, some regular Kubernetes user would never run ID, for example, in their shell.
Oh, yeah.
Or spawn a shell. I don't know how often that happens. If there are Kubernetes avid Kubernetes users here, they would know. But basically, you could also detect for these commands. So who executed ID? When someone does this, you know that basically there's a really high chance that you've been compromised.
Yeah, because the first thing you do when you get a reverse shell is type ID. I mean, you want to know what privileges you have, and maybe cut past WD to see who's on the system. So, and also we can apply some, I think, machine learning to it, because not a lot of users will run commands in production. So you can make basically, with some statistics, you can pretty easily figure out what is malicious or not. So you can find anomalies like this. Yeah,
you could even extend the system to basically have another system on top of it, which performs anomaly detection on all the alerts you have. So it will learn what do I see regularly, and then basically you can do some clustering on the data and see what your outliers are. This is for future work. Conclusion. You wanna? Okay. So as you can see, Kubernetes is a very cool tool for hacking, but since we're not evil and we want to protect the world, then we developed this Kubernetes Security Dashboard to detect the hacks. So we built it with Fluent, Elasticsearch, Kscope attached to Elasticsearch, and Kibana for visibility over your basically all your Kubernetes clusters and over the cluster activity.
And since Kubernetes version 1.13, they have some dynamic logging you can enable. I haven't played around with that yet, but once there will be more documentation available about how to do that, we can do different audit logging as well with newer versions of Kubernetes. And of course, we wish to extend and have more future work on the Kubernetes Hub, find more ways to log. Currently, I'm thinking of finding a way to let the kubelet log also into Fluent, so we can enable debug logging and actually see a lot more that's going on there. So yeah, this is definitely a work in progress, and we hope to release more information soon.
Yeah.
And yeah, we will release the Git. We'll make sure that the Nullcon conference team will tweet about the GitHub repo once we have everything live. Tomorrow we're going to spend the whole day in the hotel room to clean up our README file, make sure the documentation is correct, and then we'll release it as soon as possible. Thank you.
Thank you.
Are there any questions? You need a microphone. Just.
Yeah, so this question is a bit meta, but how are you deploying this Kscope on its own? Is it a standalone binary or?
So actually, we want to make a daemon out of it.
Yes, we're planning to make a systemd service. What is basically currently is a Python application. You can run it once to perform the static analysis.
So you have different parameters. Actually, I'll show you the entry.
Oh yeah, a bit of zooming in there.
Now you're gonna see all my files.
Make the font a bit bigger.
Yeah.
Wow.
This should be fine. Yeah. So this basically says run it on static mode from this date to now. And then if you say streaming, it will run in streaming. But we're going to basically make sure that this can be run as a system.
And since Kubernetes people like YAML, we're going to write some YAML configuration files.
Right.
But yeah, and we also will write documentation on how to deploy the Fluent configuration, what configuration items you have to add to the API server so that the mounts are correct. But we're planning on releasing this tomorrow, and then we'll let you know what the GitHub repository is, and then you can see how it's run.
Any reason you didn't write it in Go, considering Kubernetes is written in Go to begin with, and it's better off for multi-threaded applications and concurrency and things like that?
That's maybe for future work. We both prefer running Python, writing Python, so it was easier to start building this.
Okay.
But a Go port, might be useful for the future. Go and YAML, then you're basically in the Kubernetes here. Okay, thank you.
Yeah, thanks.
Any other questions? Nope. Oh, is one in? No. Okay, I guess we're done then. Thank you all.
Thank you.